Hello there again. We're going to be doing 7.5 today. And you might want to pause the screen for a second and write down all this stuff. This is all stuff we've already done in the past. It's a summary on graphing, how you graph slope-intercept with the slope and the y-intercept, standard form with the height and divide, and horizontal lines. Remember that it's always y equals a number, slope is always 0, crosses the y-axis at A, and then vertical lines is the equation is always x equals some number. The slope is always undefined, and it crosses the x-axis at B. So you want to copy that down. And today we're actually talking about inequalities, linear inequalities. And you graph linear inequalities much the same way you graph equations, with the exception that you have shading, and these boundary lines can oftentimes be dashed or solid. So they are dashed whenever the inequality symbol does not have the equal sign. So for a less than or a greater than, you are going to graph a dashed line. Whenever it has the equal to attached, then it's going to be solid. And for shading, again, if you have less than, or if you have less than or equal to, you shade below. So I have an example there of shading below, and I'll move this out of the way. And for greater than or equal to, you shade above. So just some notes for you to have. We're going to start with some examples here, and I'm going to show you how to graph these little guys. Because this is x and only a number, I know that this is going to be a vertical line. And it's nice that it's doing this weirdness over here. Let's try that again. Vertical line. And we know that vertical lines are going to cross the x-axis at, in this case, 3. So 1, 2, 3. And I'm going to, because it doesn't have an equal to, this boundary line is going to be dashed. So there I go. And because it's a less than, I'm going to shade to the left. And so this is where I shade. And that's pretty much how simple that is. It really shouldn't be dashed like that, but you get the idea. Then we have y greater than or equal to -4. So for that one, because it's y and a number, we're going to get a horizontal line and at -4. So 1, 2, 3, here's -4. And it's an equal to, so it's going to be solid. And because it's greater than, we're going to shade above the boundary. Above, 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 we shade. Alrighty, and that's how you graph those guys. And so Gavin is going to come up here, and he's going to show you this do-it-yourself problem. You're supposed to do this by yourself, so pause it, do it on your own, and then you can check it with Gavin's answer.
Hello everyone. So, we have x is greater than or equal to -2. So it's going to be a vertical line at x at -2. So we go, bam, -2. And it's going to be a solid line since it's has an equal to part. So, line. And then since it's greater than or equal to, you shade to the right of it. So, okay.
Awesome.
Okay, then for this one, since it's y is less than 3, it's going to be a horizontal line at 3. So you go 1, 2, 3, and then it's going to be a dotted line since it's not equal to. So dotted line, and then since it's less than, it's going to be below the line. Oops.
Awesome. So that's what your graphs should look like. Hopefully they do. If not, go back and figure out why. So then we're going to move on to this little guy. And this is mx plus b, but again, you're going to graph it in much the same way. I identify my slope first is 2 over 1. My y-intercept is always 0, b, and so in this case b is 3. So I'm going to graph that guy by plotting the y-intercept first. 0, 3 goes right there. My slope is 2 over 1, so I'm going to go up 2 to the right 1. Remember that you can also go down 2 and to the left 1, and you're still going to get the same line. And my bad, that line should be dashed because you have a less than, there's no equal sign attached to it. And so now you're going to do the shading, and at this point it kind of gets confusing sometimes how you want to shade. In general, if this is less than, you're going to shade below. But it's always nice to be able to use what they call a test point. So I'm going to pick the origin. And if in fact the origin is a solution, then when I plug in 0, 0, get that right someday? Okay. It's still dotted. Okay, there we go, finally. If I plug in 0, 0 into my equation as a solution, it should be a true statement. So if I plug 0 in for y, oops, and 0 in for x, what do I get? I get that 0 is smaller than 3. Is 0 smaller than 3?
Yeah.
Yes, it is. So that's true. And because it's true, I shade towards the origin. And there is my solution. Alrighty, so now Kaylin is going to come up here. And you should try to do this one on your own. And you can check it with Kaylin's afterwards.
Hey guys. Okay, so we're going to graph this equation here. So you can see from that spot right there that the intercept is -1. So there's -1. And then the slope is up 3 over 1. So you go up 3. So 1, 2, 3 over 1. And the line is solid because it's equal to the line. And then since it is greater than, we shade something like
In a cool color. In a cool color.
yeah.
Awesome, yay. So hopefully you guys got that same answer. And now we will go and try one that is graphing in standard form. When you graph standard form, you want to use intercepts. So we do our hide and divide. So my x-intercept means that I make y 0. And by making y 0, I just cover the y, and then 10 divided by 3 is 10/3. And then I get my y-intercept by making x 0. And if I make x 0, then 10 divided by -5 is going to be -2. And then I use those 2 points to graph. So 0, -2 is right about there. And 10/3 is basically 3 1/3, last I checked. So 1, 2, 3, 4, 3 1/3 is roughly right there. And this is a solid because it has an equal to. So we're going to do that little guy, solid. And now we're going to use a test point. So we test the origin, which is right here, 0, 0. And we're going to see if it's a solution or not to tell us which direction to shade. So if I use 0 for x and 0 for y, this is basically saying 0 minus 0, correct? Is 0 less than or equal to 10?
Yes.
Si, senors. So we are going to shade in the direction of the origin, which is above. Now notice that that says less than. So you might have thought to shade below, but it's actually above. So never be afraid to use a test point to make sure. That happened because that's a negative, by the way. So, anywho, now we're going to have you try this one on your own. And Jin Young's going to come up here and give you the solution. And she's awfully embarrassed about this, so.
Hi. Okay, so. Alright, so you do hide and divide. So 12 divided by 6 is 2. 12 divided by 8
No, it's
Wait,
four.
wait.
Come back. Wow, hold on. 12 divided by 8 is actually.
Wait. 4. Dividing over 2.
4 goes into 12 3
Dividing over
times.
2. Oh, this is embarrassing. So that is x, and that is y. When y is 0, when
Fancy.
x is 0.
Okay.
So that means 2, 0 on that one and 0, 3, 2. So say that's 1. About right there is 3 over 2
3 over 2 is 1 and a
Oh,
half.
wow. Okay, I'm gonna go again.
Make it.
Pencil.
No way, no way.
Hey, stop. 3 over 2.
Change
Blue
the
now.
color.
That's 2. So
Okay.
there's a dot, and there's a dot. Draw a line, and then you pick the test point, which is 0, 0. You plug it in. 6, 0, 8, 0.
Oh.
0.
Is
And that
0 bigger than 12?
Oh,
No, it's not bigger than 12.
So you shade the other
So you
part.
shade away from the origin. Mucho bueno.
Ta-da.
And that is your lesson for today. And Gavin is busy and not turning this off.
I'm playing with your son.
Awkward. Okay, bye.
Bye.
Ching chong.
That's